Hello everyone, welcome to my channel. In this video, I'll be resolving 14 CKAD questions. So here I divided my entire screen into three divisions. On the left hand side, it's going to be the questionnaire for all the 14 questions, and in the middle one is going to be the browser where I'll be using it for my Kubernetes documentation. I was on the right hand side is going to be the terminal which I'll be using to resolve all the 14 questions. So let me look into the first question. In question 1, we have to create the namespace ns1-exam1, and then we need to create a pod inside the namespace ns1-exam1, and then you have to create the second namespace called ns2-exam1, and then you need to move the pod from the namespace ns1 exam1 to ns2-exam1. And once you move the pod to the new namespace, you have to delete the old namespace. Let me go and do the first question. kubectl create ns. In case we do not know the command, you can go and search in the documentation Kubernetes commands. So use this particular one for the command. So if you go here, you are going to create a namespace, create. Under that namespace, if you click the namespace, it will give you the list of options that is needed to create a namespace. So going back to my terminal, kubectl create namespace ns1-exam1. Check the command, check whether if it is created or not. Get ns. Okay, the new namespace got created. So now within the question 1, the second one is to create a pod inside the namespace. So kubectl run pod1-exam1. In case you do not know, you can always use the command section here to find the command. Since I'm familiar with most of the commands, so that's why I'm not referring the document. Just in case if you don't know, you can always follow the document. This is a standard for even for the CKAD exam. Hyphen image equal to nginx, and you have to create with the namespace exam1. Okay, you can use watch kubectl get pods -n ns1 exam1. Okay, the container is getting created. Once the container is created, you have to create the new namespace. Yes, it's already got created. Control C, kubectl create ns2-exam1. Okay, your organization decided to move your pod 1-exam1 from the first namespace to new second namespace. So for that, kubectl get pods pod1-exam1 -o YAML, and I forgot the names, -n ns1-exam1 o YAML .yaml .yaml. So here simply I'm going to give the second namespace what we have created. 2 kubectl create -a. Okay, kubectl get pods -n ns2. Previously this new namespace will not have any pod. Now it will be having a pod. Okay, so now the last one is to delete the namespace. kubectl delete ns1 exam 1. Your question 1 is completed now. Okay, this is your question number 2. Here you are going to have two parts which you are going to create, front end and back end part. By default, all pods can talk to each other within the Kubernetes cluster. If you wanted to restrict or apply any rules, then you need to create a network policies. So for network policies, there is no kubectl commands which you need to which is basically you need to write a manifest file. First, let me go and create two parts, front end and back end. Kubectl run front end. Okay, now I created the two parts. Here, if you look at here, I need to restrict the policy, restrict the traffic from back end to front end. So any incoming traffic is called ingress, the outgoing traffic is called backend. So I need to deny traffic from backend to front end. That means I need to use egress policy to deny the traffic. Let me show you how to do that. If you go back here, get pods -o wide. I have two pods created already, backend and front end, and the corresponding IP. So kubectl execute -it backend. So from backend, I'm trying to connect with the front end IP, which I can connect. Similarly, kubectl exec front end. So I'm going to use the backend IP, which is also going to work. But basically, when I do this command, I need to restrict connecting to front end. That is what my objective here. So right now you see that for both commands, I'm getting output. After creating a network policies, I'll be getting a timeout error for this command. That is what we are going to do. Go back to your documentation, search for the network policies. Here I'm going to simply use netpol. Netpol is a short name for network policies. So go and click this first one. Since I'm going to deny egress, I'm going to search for egress in the document. Okay. I'm going to copy this. Clear the screen. Okay, I need to show you one more thing. kubectl get pods -show. So I'll be using in my manifest file these two labels. I'll show you what it is now. netpol.yaml. Okay, if you use simply the empty parenthesis like that, that means you are going to deny any part. If you go and run this blindly, you are going to restrict for all the parts. No parts is going to receive connection between the other parts, which I don't want to do, because sometimes if we are working in a multiple project, other project will get impacted. Okay, go back here. Okay, I'm going to use pod selector, which means that I'm going to restrict connectivity from backend to front end. So I need to tell what is my pod selector, which is nothing but match labels run equal to backend. So from backend, I'm going to restrict to front end. kubectl create -l. Okay, now if you go and execute the same command what you execute before, it's not going to work. White kubectl execute -it from backend. I'm trying to access the front end IP previously which worked, which is not going to work now. It's going to take longer time, and finally it will going to throw an error as timed out. Since it's taking longer time, that means it's trying to connect, but it's not going to get connected. Simply I'm giving Control C. If you do the other one, kubectl execute -it front end, which this is going to work. Okay, so with this we are completing the second question. Let me solve the third question. Kubectl create deployment exam1 deployment image equal to nginx for 1.25 replicas equal to 2. kubectl get deployment. Okay, this might take a little longer. So basically, if you look at here, out of 2, 0 are available. So basically it has to come 2 by 2. We'll wait until it becomes 2 by 2. Okay, it's 2 by 2 now. That means 2 replicas are getting created. Okay, now if you go at the question 3, increase the number of replicas from 2 to 3. So kubectl edit deployment name is exam1 deployment. Go here and simply find out where is replica, change from 2 to 3. Okay, now if you go and see kubectl get deployment, previously it was 2, now it will be 3. You see here 3, and previously it was 2 by 2. It will take some time to increase to make sure. We have to make sure that 3 by 3. We have to always make sure how many replicas what we create. It has to create that many things should be ready and available. Let us wait for a few seconds and then we can go on find out the other questions within the question number 3. Okay, now you see 3 by 3 is available. Now check out the history. kubectl rollout exam1. Okay, it means that only so far one changes happened so far. Now, if you go back to your question, now we have to change your image from 1.25 to 1.26. For that, this is the command kubectl set image deployment exam1 deployment. So basically, the container name is nginx equal to. I'll show you where I'm taking this nginx. I'll open the YAML file and show you shortly. And nginx colon 1.26. kubectl get deployment exam -yaml. If you look at here, the one I showed you earlier, under the container section, your container name is Nginx. That's why I gave the command like you look at here, I gave Nginx equal to Nginx colon. This is nothing but your container name. Okay, now we'll go and look at the history. Rollout history, deployment, exam1. Previously it was 1, now you will be seeing second one. Okay, now we need to do a rollback to the first revision. We can do it in two ways. kubectl rollout undo. If I give the rollout undo, since only 2 version, it will go back to 1. If you wanted to go back to specific version, then this is the one. This is the command what you should give. Deployment exam1 deployment -2 revision equal to 1. Okay, if you notice clearly, your version 1 is 1.25, version 2 is 1.26. Now I roll back. So if you look at my history, if you go and describe the deployment, kubectl describe deployment exam1 deployment and grep with image, it will be 1.25 since we rolled back. That's what perform rollback to first revision and ensure the image equal to Nginx 1.25. With this, we are completing the question number 3. Okay, here we are going to solve the fourth question, which is related to the service. We are going to create a part, and then we are going to expose that part with the name svc part for -exam, and then we need to access this part outside the Kubernetes cluster. For that, we are going to use node port. Default is cluster IP. Instead of cluster IP, we are going to use the type as node port, and we are going to use the port number 31000. Let me show you how to do that. kubectl run port 4 -exam1 age equal to Nginx port equal to 80. kubectl expose pod svc pod 4 -exam1 container port equal to 80. Okay, so I have to give the pod name pod 4 -exam1 and name equal to svc pod 4 -exam1. kubectl get svc Okay, if you see here, the default one is cluster IP and container port is 80. Now we need to change the cluster, the type to node port, and we need to access this pod through the services outside the Kubernetes cluster with the port 31000. Let me go and edit the services. Okay, you can also do this by looking at the document. Go for node port, and when you search for the node port, you will see the services one. Click this one. Always make sure that you are within that kubernetes.io/docs, because this is the one what it is allowed to use in the exam. kubectl, going back to my terminal, edit, and Okay, first change the type to node port. And remove all these lines which is not needed. And okay, I didn't search for that. Okay, search for node port, control F, node port. Okay, if you look at here, I changed the type as node port. Exactly is given here at the spec level, right? And then inside the port, I'm going to make it to 31,000. Going back here, inside the ports, node port 31,000. If you look at the description of that, you can see the type. Previously it was cluster IP. Now it's become node port, and port is 31,000. If you wanted to access outside the Kubernetes cluster, kubectl get nodes, kubectl get nodes. So I'm going to my browser. So this my browser is actually outside the Kubernetes cluster. So I'm going to use IM, someone else, and 31,000. Basically, it will give you the Nginx one. Okay, that means we are good. With this, we are completing the question number 4. Okay, let's coming back to the question number 5. It is to test your knowledge on your Docker and containers. So the one in the yellow box is nothing but your content of a Docker file. Just for the interest of time, I already placed my Docker file. So if you look at here, I don't have any Docker images. Here I'm going to create the image, and then I need to tag that image and push that image to the Docker app. And then finally, I'm going to use this Docker image into my Kubernetes cluster. Let me show you how to do that. First, you need to do Docker build -t, and I am someone else Docker demo question 5, and you have to give the location where is a Docker file is located. I'm going to say it's the current directory. Okay, now if you go and look at Docker images, you'll be having one. Okay, now I need to push this Docker image to the Docker app. For that, Docker push. So I can simply use this one and copy and paste it. Okay, now I need to use this particular image in one of the sample part, which is nothing but, let me go and create kubectl run test pod, or I can give some relevant to question 5 -pod -image equal to I am someone else Docker demo question 5 code equal to 80. kubectl get pods. Okay, if you see the new pod which is getting created, let me show you. kubectl describe pod grep -i image. Basically, to make sure, just showing that I'm downloading, I'm creating this Docker container from the image what you have created as part of the question number 5. With this, we are completing question 5. Okay, let me look into the question number 6. This question is related to security context. First, before going into the question, I want you to understand what is UID 1000, so that way it will be easier for to understand. If you go to my terminal, if I type Jenkins is my username. If you look at here, the user ID is 1000. Okay, that means if I use this using Jenkins as a user, if I go and run few activity inside the pod, what it will happen, whether sometimes you might not have this Jenkins user might not have access to the container that is already running with the Nginx latest. So that's why you might get error. Since I already tested, it will throw an error. If you look at UID as 0, I'll show you what is UID 0 is. ID root, it is nothing but your root. When you run as a root, you will not get permission denied. Let me show you what it is exactly. So simply go to your documentation, search for the security context. If you look at here, there is a security context run as user. I'm going to give 1000 and show you what is going to happen. kubectl. Let me create a part. Run pod 6 hyphen exam1 image equal to nginx. Okay, I'm not going to create. I'm simply going to rewrite to the YAML file -o YAML. I'm going to save it like 6.yaml file. Okay, when you do a dry run equal to client, it will basically if your command is right or wrong, you can validate by using this command. So okay, go and open your 6.yaml using the VI editor, and here just follow the document. So add a new line, security context, run as user 1000, kubectl create -f 6.yaml. I'm getting some error. Let me check. Oh, escape. kubectl get pods pod 6 hyphen exam1. You see there is an error. Let me go and check the logs. Pod 6. You see there is a permission denied because the user 1000, which is nothing but your Jenkins, the user ID which I used to run all my kubectl command, does not have permission to this particular directory. It's trying to create directories. For some reason, it's not having the right permission. So going back to my YAML file, instead of 1000, I'm going to 0. As I mentioned before, 0 is nothing but your root ID. kubectl delete -f 6.yaml kubectl create -f 6.yaml. While this is creating, I just wanted to show you something. The security context can be applied at the spec level and also the container level. If you have multiple container, let's say your pod can be running as one user, but if you want to use that container for different username, that also possible. Maybe I'll show you in the same documentation. Yeah, if you look at here, the security context here at the pod level is run as user as 1000, but inside your container, there is a possibility of you can run it as a different user. Okay, kubectl get pods pod 6 exam1. Now the pod is running without any issues because you change the run as user as root user. That's how you resolve this problem. With this, we are completing the question number 6. Coming back to question number 7, basically you have to create a config map. The first literal is db underscore host and the value is Postgres host, and then we have the second key value pass, and then you need to pass these two variables as a volumes in the section 2 of the question number 7. In the last part of that question where you need to pass as the environment variable. Let me show you how to do that in my terminal. Let me clear it. Okay, if you wanted to know how to create a right, and just to refresh you, so just go here, create, and there will be a config map. So in case you don't know what is the command to use and how to use, always use this document and find out what command are you going to use and find out their respective resources. Okay, kubectl create cm. My config name is 7-config exam1, and from literal equal to db underscore host equal to Postgres host, and second literal is equal to port equal to 5432. Okay, I have created the get cm. You see here, I have created the config map. Let me describe it. Describe cm. Yeah, you can see two values, db host and the port number. Okay, we now within the same question, I need to pass this information as volumes. Okay, let me show you how to do that. kubectl run. What's the name of the pod? Pod wall config exam1 image equal to nginx try run equal to client -oyaml .yaml vi 7.yaml. Come down. Okay, go back to your document. In case you do not know how to do, go and search for config map. Click the kind pod. Yeah, there are 3 ways where you can do, but here we are going to use as a volume to look at here. So this is what we are exactly going to do. Escape go volumes. If a name, you can give any name, test wall So if you look at here, it's going to be a config map, and your config name should be seven config-exam1. This should match with the config map what you have created already. And then coming inside your container, you need to give volume mounts. Yeah, you can simply follow what is there in the documentation. I created the volume. This section is complete, and now I'm doing this part. Volume mounts. This should match with what the volume name, and then mount path. Mount path I gave it in my question /etc underscore config /etc config kubectl create -f7.yaml. Okay, kubectl get. Let me see if this part is running or not. Yeah, still creating. Let's give a few seconds for that to get created. Okay, it's created now. kubectl execute -it. We are making sure if the directory, basically that's etc/config is nothing but it's going to be a directory inside your pod, inside your container, and then you are going to check whether these two variable exist inside the directory etc config. Okay, let me go inside and pod wall config /bin/sh dd slash here add port. You see here 5432 add dbhost. You can see Postgres host what we have created here. So now we have completed 1 and 2. We are moving to the third one. Exit. So now let me do kubectl run for env config image equal to nginx hyphen try run equal to client no yaml 7a.yaml file. Okay, vi. So let me clear the screen for some time. vi 7a. Okay, so now this is one way where you can pass the configuration map through your volumes. The second step is that you can pass it as an environment variable. If you go inside the same document, little bit scroll up, there would be a way. Yeah, see here. Environment from config map rep, and then you have to give the name. We are going to follow the same what is there in the document. Seven, you have to give the one what you created, the config map config -exam1. kubectl create hyphen f only kubectl get parts env. Okay, it's running. Okay, kubectl execute -it for env config env. If you see here, the environment variable what we configured, the db host and every both is displayed here. So that means you successfully pass these two config map key value pairs as an environment variable inside this part. So with this, we are completing the question number 7. Okay, for the 8th question, it is actually two different questions. The one is a separate question, 2, 3, and 4 is another question. Let me show you how to resolve it. Clearing my terminal. So here, the first one, they are asking to create a pod with the resources. When you see the request equal to 100 MCPU, that is nothing but you have to use the resources. The resources is a limit range. So basically it is a lower limit, and when you see there is a limit, that is a upper limit. Let me show you how to create the part with the parameters given in the 8.1. Okay, go to your documentation. Search for resources. Okay, not you cannot use this, not under documentation. Okay, it's not still under documentation. I'm going to copy this one. The instead of copying, I'm going to edit it. Equals memory. Memory is 200. CPU 100 and limits. Memory. The maximum maximum limit 500. CPU. Okay, that's it. kubectl create -f 8.yml. Sorry, I'm spelling mistake. kubectl create hyphen. Okay, so 8.1 is complete. So let's go to 8.2 to 8.4. In 8.2, you are restricting the namespace ns8 not to have more than two parts. That means your replica count should not exceed beyond 2. Okay, let me go and create the resource quota. In order for you to create a resource quota, go to your documentation and look for the quota. Okay, and this is the command what you need to create. kubectl. Before that, let me create the namespace. kubectl create ns8 kubectl create quota odd equal rqs odd equal to pods equal to 2 hyphen n ns8. So you have created the quota which can hold only the maximum replica count as 2. Now you are trying to create the deployment name test quota image equal to nginx, and your replica count ideally should contain only 2, but I'm giving more than 2, which is 3 here hyphen n ns8. If you watch this Kubernetes deployment kubectl get deployment hyphen test quota hyphen n ns8, it will, if you see, the number of ready will not exceed beyond 2, which means that you will get ready as 2 will be ready out of 3. Okay, so the reason is that you have restricted the number of deployment to keep only 2. For that, I'm going to edit the deployment. kubectl edit deployment test quota hyphen n ns8. Go and change the replica count to 2. Okay, which is good now. With this, we are completing the question number 8. So in question 9, we are going to create persistent volume and persistent claim, and then we are going to use that persistent claim, volume claim in the pod manifest file. So as you all know that the persistent volume and volume claims give the flexibility of statefulness, and pod is ephemeral. That means whenever you delete the pod, the amount within the pod will also get deleted. But when you use this mechanism, you can always make sure that the file what you get created and mounted to that pod will always exist. That is what we are going to do it in this question number 9. So further, go back and search for persistent volume, and then click configure and click this one. Okay, and you can click either of these two, but this is better. So vi pv.yaml for creating the persistent volume. For this, I'm going to copy this. Insert. The name of the persistent volume is logs pv logs hyphen pv exam1. I don't want to. This also I don't want. Capacity is 2 gig. Change it to 2. And it is access mode is read write once. And here I give var log. Var logs. So ppc.yaml. Now I'm going to create a persistent volume claim. So copy this. logs hyphen pvc hyphen one. I don't have any storage class in my requirement, and request here is to use 1 gig. One. kubectl create hyphen f pv.yaml. Okay, if you go and look that get pv, you will be seeing it as available, but it has to be bounded. So once you create the run, once you execute the manifest file of pvc.yaml, you'll see the difference. kubectl get pv pvc. Okay, previously it was available, now it's become bound. Similarly, if you look at that kubectl get pvc, that will also be in a bound state. Okay, so now we are going to use this claim inside our pod manifest file, which is 9.c. Okay, going back, kubectl run pod 9-exam1 image equal to nginx. Try run equal to client hyphen o yaml 9.yaml vi 9.yaml. Okay, here what I'm going to do, I'm going to use this one. I'm going to use this documentation to alter my 9.yaml manifest file. Go here, volumes, name, put test hyphen vol, it can be any name. So I'm going to use persistent volume claim, then volume claim, and you need to remember the name of the claim, what is used. Claim name, our claim name is logs hyphen pvc hyphen exam1. Okay, and then coming inside the container, volume mount name test wall and mount path. So here I gave var logs nginx. Okay, there's a typo, it's actually var logs. Okay, I think that's it. I'm making sure if my claim name is this one. Let me double check. Okay, logs hyphen pvc hyphen exam1. Yeah, that is right. Let me go and run the manifest file. kubectl create hyphen f 9.yaml. Okay, it's got created. kubectl get pods pod 9 exam1. Still creating. Yeah, it's running now. Okay, so what I'm going to do, if you look at the question 9, we are done, but we have to create a file called 9.log inside the directory where logs nginx. Sorry, there is a typo here, where /log/nginx. kubectl execute hyphen pod 9 exam1 in cd nginx. I'm going to touch. You look at here, there is no file called 9.log. Touch 9.log. Okay, I'm coming out exit. So generally, once you come out of your pod and if you delete the pod, the storage, whatever that is part of the particular pod, will also get deleted. So I'm to just show you that it is once you have your persistent volume and claims, then your state of your pod will be stateful. Okay, so otherwise the whatever the volume that is inside the pod will be always ephemeral. Whenever the pod deleted, the storage will also get deleted, but in this case it will not get deleted. So let me show you that. kubectl delete -f 9.yaml. kubectl create. You can try the same thing without the storage, where you will see that 9.log will not exist under the nginx. Now it's got created. Still creating. Okay, running. kubectl execute -it pod 9 exam1 cd/where logs nginx. If you go and do ls-ltr, you will see the 9.log. Okay, generally if you delete the part, you will what are the file that you created will also get deleted. But since we have created with persistent volume and claims, that's why you see that 9.log is even still exists even after you delete and recreate the part. With this, we are completing the question number 9. Okay, in question number 10, we are going to solve the probeness. Basically, you are going to check the health of your part, right? So there are 3 types of probe: start probe, liveness probe, and readiness probe. For this example, we are going to see liveness probe. So let me create a part. CTL create pod. Sorry, run pod 10 exam1 variable nginx try run apply OYAML .yaml v8 10. Okay, so now going to the documentation, I'm going to search for liveness probe. So in our case, we are going to do a liveness probe for the port 8080. Okay, so what basically it will do, once you deploy your container, it will go and check whether you can access your pod for the port 8080. But we all know nginx port is exposed to 80. For intentionally, I gave 8080 so that it will throw an error. Okay, and what initial delay seconds as 5? It means it will take first 5 seconds to start up the part, and timeout as 2 seconds, and period seconds is every, in case of failure, it will stop, kill the container and restart. That is what, for that we are giving 10 seconds. But for the interest of time, I'll make it like a 2, 2 and 5. Let me go and add a liveness probe inside the container. Okay, I'm doing the HTTP port, so I need to refer this one. Port equal to 8080. Okay, I need to add if you don't give any of these initial delay seconds or timeout, it will take the default value. So for now, I'm going to, just for the interest of time, I'm going to give the lower value. Initial delay second to kubectl create -f end.yaml. Okay, if you look at here, the why I'm wanted to show this. So since I gave intentionally 8080, which is supposed to be 80. So if you see, we gave like a 2 seconds, and then we gave a period seconds as 2, and then a timeout. So every 6 seconds, it will try to check the liveness of that part, whether it can access the port 8080. If it is not accessed, then it will try to do a restart. Already the restart, yeah, I said to restart. If you look at here, it will try to do a restart. Yeah, see here, it was trying to check the port 8080. Is not able to hit that URL with a slash, and then it will wait for some few seconds, whatever that we have mentioned in the liveness probe. It will wait until that time, and once it reaches the limit, the status of the job from running, it will become, go back to crash back. So yeah, see here, this is what I was trying to say. After it reaches some time, it will go to the status crash loop back. Okay, now going back, let me do a control C. Let me describe this. What is the error? kubectl describe ports. Yeah, connection refuse. Liveness pro fail. Everything is good. Only it cannot try to launch the port 8080. That's why it's throwing an error. Let me change the YAML file to 80 and redeploy it to fix the problem. Cube vi 10.yaml. Takes time. It might be pulling the image. Okay, sorry, I just only deleted it. Kubectl create -f end.yaml. Okay, so let me go and check the lab. Kubectl describe pods. Previously, what we have seen is live nodes fail. This time, it will not have any error. The liveness is successful. Okay, if you see here, it's try to hit the URL :80. That's why you don't see any error. Okay, with that, we are completing the question number 10. Yeah, question 11 is the easiest one. Let me go and solve it. Kubectl run busy box even exam3 is an image equal to busy box hyphen vehicle tips on it. Okay, kubectl get pods okay, it's completed. Kubectl logs and checking. Yeah, so we have completed the question number 11. This is an interesting question, so please pay an attention. This will clarify all your services and endpoints and label concept. So let me try to resolve this question number 12. Going back to my terminal. Okay, first I'm creating a pod, delete pod with the label as delete this pod. Kubectl run delete pod hyphen image equal to nginx port equal to 80 -l denotes a label app equal to delete this part okay, so execute kubectl get pods delete pod hyphen show label. Okay, and then hyphen o white. I'll tell you why. Okay, maybe once the pod is created, I'll show you certain things. Let me clear it. Let me expose this part. For that, for me to, in order to expose this part, this has to be up and running. Okay, it's running. So the pod is running with the IP which ends with 25, because this is very important. I will show you why I'm calling out this IP now. Okay, now going back, we need to expose this pod. When you expose the pod, it will create a service. It will create a service name. It will create a service. Kubectl expose pod. The pod name is the one we created, delete pod, and port is equal to 80, and name of the pod hyphen name equal to SVC 5 exam 3. Okay, so if you go and do this kubectl describe service SVC 5 exam 3, you see the IP address of the pod. You can see it in the endpoints. Okay, so that is how your service will discover your pod based on the label selector. Okay, I will because there is a question related to this, which will touch base on that shortly. So now in 12.3, so we are done till 12.3. Now we are going to delete the part. What are the part that we created? We are going to delete that part. kubectl delete part. Okay, when you delete this part, the endpoints, whatever you are seeing here, is going to become a none. Let me show you that. So now part is deleted. I'm going to describe the service again. Previously, where you see endpoint with the IP address of the delete part, now the endpoint is none. Okay, with this we are completing 12.4. Now we are going to create the new part kubectl run. Let me clear the screen. kubectl run pod 5 exam 3 image equal to nginx and port equal to 80, and I'm creating a label equal to -l app equal to pod 5 exam 3 pod 5 exam 3. So what I'm basically going to do, get pods, I'm going to rewire my service from the previously when it was connected to delete part. I'm going to rewire that to the newly created part. That's what I'm trying to do here. Created and wide. Okay, and if you wanted to see, show label, because this is very important. The label is very critical between the connectivity between pods and service. Okay, now if you go and edit your service, the SVC, the one what we created as part of this question, we are going to edit that service. So previously this service was pointing to delete part. Instead of delete part, I'm going to change the label. Okay, so don't worry about this particular label. This can be any name, but very important thing is to change the label name here, selector, under the selector section. This is how your service will discover what pod to call. So in my case, the newly created pod name label is pod 5 exam 3. So previously your service endpoint is none. After this, your service description, when you do a service description, it will be having the new IP. Let me show you that. kubectl describe SVC 5 exam 3. You see here, first it was pointing to 25, and then when I delete the delete part, it became none. And then I change the selector in the service YAML file by pointing to the label of pod 5 exam 3. Now you see the endpoint is pointed to newly created part. That's how you can do the rewiring. Okay, with this we are completing the question number 12. Okay, in question 13, regarding the horizontal pod scaling, so basically here we are going to create a pod with replica 1. then once you create a auto pod horizontal pod scaling, it will automatically increase to replica 2. And but even though I just gave you that your CPU utilization when it reaches 65 increase between 2 to 5. When it reaches beyond 65, your replica count will increase from 2 to 5. But we are not going to increase the CPU utilization here. But however, we are going to show you that the replica count 1 is increased to 2 based on the horizontal pod scaling. Let me show you how to do that. Going back to my terminal and go to your 1, and here if you look at here, there is something called auto scale. If you simply wanted to increase the number of parts, then you can just use the scale. But if you wanted to use auto scale based on the behavior of CPU utilization or memory, then you can make it auto scale. Okay, but here I'm going to increase from replica 1 to 2 using the HPA. Let me go and create the part kubectl, create deployment, query is 8 exam3, image equal to nginx hyphen replicas equal to 1. kubectl get deployment 8 exam. Okay, if you see here, the number of parts is going to be 1. Okay, now I'm going to run a command for the horizontal pod scaling. So this is a command kubectl auto scale deployment. Okay, let me go and run this one. kubectl auto scale deployment name is qvs, and I'm going to make the minimum equal to 2, max equal to 5, even CPU percent equal to 65. Okay, let me go and run it. Okay, now if you go and look at the previous deployment, previously you see 1, which is going to increase to 2 now because of the condition what we said, 2. Let's wait for a few minutes. It will automatically bump up to 2. Okay, you see here previously it was 1, now it's getting increased to 2. Okay, with this we are completing the question 13. This is a final question in this video. So here we already saw the probes. There we did a liveness probe based on the HTTP port, but here we are going to use we are going to test the liveness by reading a file inside the container. Okay, let me go and create this. Clear kubectl create run port 10 xm3 page equal to bc box run client -yaml /bin /sh vehicle date /tmp/abc abc.txt leave 600. Okay, let me redirect to 14.yaml vi.yaml. I'm just making sure everything is good. Okay, now I need to add the aliveness probe. Go down. Right. Going back to the documentation. Since we already opened the liveness probe, I'm going to, instead of previously we used path and port, now we are going to use CKAD command. Liveness probe exec command cat /tmp /abc.txt. If you give a different file, you will get file not found. Maybe just to show you the advantage of liveness probe for the cat command, I'm just doing the typo error by adding abc another c here, and then escape O. And here in the liveness probe, I'm adding the initial delay seconds as 2, period seconds, and it can be any seconds, 5, and then a time mode second. Time mode seconds as another 5. Let me go and run this. kubectl create -f 14.yaml. Okay, if you describe this, kubectl describe pod okay, it says successful, but it had to execute the liveness command. Describe again. You see here no such file or directory, because your Kubernetes, okay, let me open the file CAD 14. I'm printing the $date to the abc.txt, but instead of abc.txt, I'm trying to look at the abccc. There is a typo error, so I'm going to fix this now. vi 14.yaml changes, fix it. kubectl delete -f 14.yaml. It's taking time to delete, but generally it takes like hardly 1 or 2 minutes. Okay, kubectl create, let me clear the screen. kubectl create -f 14.yaml. So this will recreate. Now you will not be seeing any of this error. Okay, now kubectl get pods pod 10 -exam. Okay, still creating. It's running now. If we do this kubectl logs pods 10 -exam 3, that is no error. kubectl describe on pod 10 -exam 3. Previously you saw file not found, that will not be seeing it. That means we are good. Okay, hope you like this video. If you like it, please like it and subscribe it. Thank you.